So we study about equilibrium and its types. Equilibrium and its types. So basically equilibrium is of three types. One is stable equilibrium, one more unstable equilibrium, and third one is neutral equilibrium. So we will study one by one all the different types of equilibrium. First of all, we write about stable equilibrium. So what is stable equilibrium? We can write the definition of this. This is the type of equilibrium where if the object is displaced from equilibrium position, then it returns back to the equilibrium position. This basically means that in this case, in stable equilibrium position, the potential energy is minimum. So it means that if we draw the graph of potential energy versus x, suppose I draw it like this. So at this position, the potential energy is minimum. So this is a point of stable equilibrium. This is one more point where the potential energy is minimum. So this is also position of stable equilibrium. Now at the stable equilibrium position, if we draw a tangent, then this tangent will be parallel to x-axis. So it means that at stable equilibrium position, du upon dx is equal to 0. Du upon dx is equal to 0. And suppose I take just before the equilibrium position, So it will be like this. Slope will be negative. Then at stable equilibrium, slope will be 0. And after stable equilibrium, slope will be positive. So I can say that wherever there is stable equilibrium position, slope is increasing. It means that double differentiation of x is positive. So for stable equilibrium position, these two conditions must be satisfied. One time differentiation must be 0 and double differentiation must be positive. Now basically what happens in case of stable equilibrium? The force always acts towards the equilibrium position. Suppose f and x graph is there and this is a graph. Now this position is equilibrium position because force is 0. If we have a look at it, then from this equilibrium position, if we go forward, the force will be negative. Negative means that it will be directed towards negative x-axis means towards the equilibrium position. And if suppose there is a point which is before the equilibrium position, so the force, we can see that the sign of force is positive. It means that it is in this direction. So for fx graph, one thing which we have to remember is that f is 0 and df upon dx must be negative. So these are the two conditions for stable equilibrium. Suppose potential energy, we need to find out in terms of potential energy. So these were the conditions that du by dx was 0 and double differentiation d2u by dx square is positive. And for force, force must be 0 and differentiation of force must be negative. After this, we come to unstable equilibrium position. Unstable equilibrium position. We can write here. This is the type of equilibrium in which when the object is displaced slightly from the equilibrium position, then it does not come back to the equilibrium position. Now, In case of unstable equilibrium position, the potential energy is maximum. It means that if we are given a UX graph like this, so at all the points where the potential energy is maximum, we will have unstable equilibrium. Now, at this point, there will be unstable equilibrium, and at this point also, there is unstable equilibrium. Now, at this point and at this point, the slope of the tangent is 0. So we can write that du upon dx is 0. Now, before this point, you can see that the slope is positive, and after this point, the slope is negative. So it means that slope is decreasing. So double differentiation is negative. So these are the 2 points that for unstable equilibrium position, one time differentiation is 0 and double differentiation is negative. If we have to do in terms of force, so we can simply see this diagram. Suppose there is an fx graph, and suppose there is a graph which is given like this. So this is the position of unstable equilibrium. Now, if just have a look at this graph, if suppose we go a little bit far away from the equilibrium position, so the force will be positive. Positive means in this direction. So it is directed away from the equilibrium position. Now suppose there is one more point. If suppose we go a little bit backward from the equilibrium position, then force will be negative. It means that it will be directed in this direction. So in both the cases, we can see that force is directed away from the equilibrium position. So we can just write it down. First thing is that force is 0, and other thing is that dF upon dx is positive. This is just the opposite of stable equilibrium. In stable equilibrium, dF upon dx was negative, and in unstable equilibrium, slope of the fx graph, which is dF upon dx, it is positive. The third category of equilibrium is neutral equilibrium. In neutral equilibrium, the particle neither has a tendency to go towards or away from the equilibrium position. Now, we can like say here that the potential energy is neither minimum nor maximum. It means that as we have seen that in case of stable equilibrium, double differentiation of potential energy was positive, while in unstable equilibrium, double differentiation of potential energy was negative. Now, in this case, what happened? Du by dx is 0 and d2u by dx square is also 0. So the graph will look like this. Suppose u and x graph. There will be a graph, and this graph will be constant, and then it will again go down. So what happens is in this part, it remains in neutral equilibrium because in this part the slope is also 0 and the differentiation of slope is also 0. If in terms of force we need, so we can also make the diagram. In case of force, the diagram can also be like this. Like in this part, force is 0 and differentiation of force is also 0. So we can write here F is 0 and dF upon dx is also 0. So let us have a look at this question. It says that the potential energy of a particle in a force field is U is equal to A upon R square minus B upon R, where A and B are positive constants and R is the distance of the particle from the center of the field. For stable equilibrium, the distance of the particle is, and they have given four options. So we have to simply use the logic that one time differentiation of u will be 0. So u is equal to a and r to the power minus 2 minus b and r to the power minus 1. So du by dr will be minus 2 a r to the power minus 3 and minus 1 b r to the power minus 2, and this is 0. So we can get it minus 2 a upon r cube plus b upon r square is equal to 0. So b upon r square is equal to 2a upon r cube. So we can simply cancel it r square and we will get only 1r. So r will be equal to 2a upon b. So the correct option will be option number B. So let us see one more question. If u is equal to a upon x to the power 12 minus b upon x to the power 6, then find the stable equilibrium position. So again, for stable equilibrium, we have to simply apply the rules. U is equal to a x to the power minus b x to the power minus 6. So du upon dx will be minus a x to the power minus 13 minus minus 6 b x to the power minus 7, and this should be 0. So we will get minus 12 a upon x to the power 13 plus 6 b upon x to the power 7, and this should be 0. So 6b upon x to the power 7 is equal to 12a upon x to the power 13. So we will cancel this and we will get x to the power 6. So x to the power 6 will be 6 to the 12, 2a upon b. So x will be equal to 2a upon b to the power 1 upon 6. Now, although it is not asked, but still, if suppose they ask us what is the minimum potential energy, so we have to simply put this value of x in the formula of u. So u is a upon x to the power 12. So when we will do 2a upon b to the power 1 by 6 and whole to the power 12, we'll get 2a upon b square minus b upon x to the power 6. So it will be 2a upon b. So u will be a upon, and there will be 4a square and again b square minus b upon then 2a, and b will also be there. So we will get b square upon 4a minus b square upon 2a. This will be u minimum, and it will be minus b square upon 4a. This is one more question which is related to the force and x graph. It says that the force acting on a body moving along the x-axis varies with the position as shown, and this is the fx graph. They have asked that the body is in stable equilibrium at x equal to x1, x equal to x2, both x1 and x2, neither x1 nor x2. Now obviously, at the two positions where force is 0, equilibrium must be present. But we can see that only at this point, at this x2, the slope of the fx graph will be negative. So this will be the position of stable equilibrium. I hope the concept of equilibrium is clear to you all. That is all for this lecture.